going to be some times that we have to do that, because for some of these, it's pretty easy to find the inverse. So we're going to see some things that we can't find the inverse of, so we are definitely going to have to do that. So, all right, so if we are looking at this question, okay, h of x equals x squared plus 1, only for x is greater than or equal to 0. They're restricting your domain here because if your inverse is not a function if you do not. So if I want to graph h of x, and I'm only using 0 or greater, so 0, 0, 1, 2, 3, 4, 5. So 0 squared plus 1 is just going to give me 1. 1 squared plus 1 will give me 2. 2 squared plus 1 will give me 5. 3 squared plus 1 will give me 10. I could keep going here. Actually, I might need to keep going. I'd have, let's see, 16, 17, and then I'd have 26. Okay? And so, obviously, that's not all going to fit on my graph here, but I'm going to graph what I can of that. So, I've got 0, 1, 1, 2, 2, 5, 4, 3, 10. Right here. And so, if I'm thinking about the inverse of that graph, I've got 1, 2, 5, 10, 17, 26, and 0, 1, 2, 3, 4, 5. So that is going to be 1, 0, 2, 1, 5, 2, 10, 3. Label this here too. This is h inverse of x, and this is just our h of x. Now, what they're asking us for is the derivative at 5 on our inverse. That's this point right here, the point 5, 2. So I could find the inverse, but if we notice what we just saw, what's the corresponding point on the actual function? It was 2, 5. So 2, 5 is right here. And let's think about the slope of that tangent line, okay? Because if I want the slope of that tangent line, h is a lot easier to deal with than the inverse, right? So h prime of x would just be 2x. And so h prime of 2 would be 2 times 2, which would be 4. So the slope of this line is going to be 4. So the question wasn't asking us for that. The question was asking us for this slope right here. What do you think it would be? It's going to be 1/4. And so 1/4 would be our answer for that. This one, you could do the inverse. You can switch your x and y, solve for it, take the derivative, plug it in. You could do it that way. But the original function is easier to deal with. So that makes it easier to approach it this way. Let's look at this one. Okay, we've got g of x equals e to the 3x. We want to know g inverse prime of e squared. Okay, so we could approach this either way. This one's definitely not going to be as easy to make like a table for, to think about those values. So let's do, I'm going to do two different ways. So let's do this way. We're going to find the inverse. Okay, so one way is that we can just find the inverse, right? We can switch our x and y's. So we'll have x equals e to the 3y. And if I'm solving for that new y right there, what do I have to do? I'm on natural log. Both sides to get rid of that e. So I've got the natural log of x equals 3y. And then what do I have to do? Divide by 3. So g inverse of x is going to equal natural log of x over 3. Okay, I'm going to take the derivative. I'm going to write it this way. It's going to be 1/3 times the natural log of x. That just helps me wrap my mind around how to do it a little bit easier. So if I want to take the derivative of this, so g inverse prime, the notation gets kind of ugly there, but just g of x, put it in some brackets, put a little prime there to show you're taking the derivative. The 1/3 is just a coefficient. What is the derivative of natural log of x? 1 over x. Okay, so we will just get 1 over 3x. And so if we want to find g inverse of e squared prime, it was e squared, wasn't it? Yep. We're just plugging it in. So we got 1 over 3 e squared. And we'll just have to leave it that. Okay, so this might even be the easiest way to approach it on this particular problem. But let's try to think of it like we just did with our graphs. Okay, and in fact, I'm going to graph this on Desmos so we can think about what it looks like. So I've got g of x equals e to the 3x. And then the cool thing about Desmos is if you want to graph the inverse, you can find the inverse, but we're trying to do this without finding the inverse. If you're on Desmos, you can just do x equals e to the 3y, and it'll graph the inverse. Because when you switch your x and y's, that is the inverse. So it'll graph it there for you. We are finding g inverse prime of e squared. So that means that this is the x value on g inverse of x. So like on our graph over here, if I type in x equals e squared, and I'll try to zoom out a little bit. So we're talking about that point right there. Let me just, come on. Oh gosh. 7.389. Okay, so we're talking about that point right there. That's where our x value would be e squared. Okay, so if it is the x value on g inverse, what is it on the original equation? It is the y value. So it is the y value on g of x. So what we can do is we can take g of x, and we know that we're getting e to the 3x, and the y value ends up being e squared. This is a little confusing here because it's not a number right here, right? So if I want to figure out what the x value that goes with that is, because I'm looking for that corresponding point, right? Like where that corresponding point is, I could just natural log both sides here. And so 3x equals 2, and divide by 3, and you got x equals 2/3. So the point 2/3 e squared is on what is it, g of x here. So if I do 2/3 e squared, you can see that's the corresponding point on that graph. This is an alternate solution, like a different way of doing it. So my answer for the question is 1/3 e squared, and I could just do the problem that way. So this is just like an alternate way of looking at it, but I want to do it this way because we're going to see some where we can't find the inverse. So we're going to have to do it this second way. Okay, so what was my x value here becomes my y value here, so I set it equal. I solve, I get my point, and then if I can find the derivative at that point, then the inverse is just going to be the reciprocal of it, right? So g of x just equals e to the 3x. What does g prime of x equal? Nope. It's almost just e to the 3x. The derivative of an exponential is itself, except you have to multiply by the derivative of the inside. There's a chain rule here. And what's the derivative of your 3x? 3. So there is your derivative of g. You can do g prime of 2/3. And that's going to be 3e to the 3 times 2/3, which is going to be 3e squared. So if g prime of 2/3 is 3e squared, g inverse prime of e squared, because you got to use the y coordinate here, is 1/3e squared. Okay, I would possibly even argue the first way is easier, but we're going to run into some of these where we have to do it that second way. Questions? All right, so one of the things you had to do last night is prove that things are inverses, and to do that, you would show that f of g of x equals x, right? So if f and g are inverses, we would show that f of g of x equals x. So we are going to write a proof here of why we're going to come up with a formula for what we've been doing on those first 3 problems, right? So I was finding that corresponding point, and I was flipping the derivative there, and so we're going to come up with a formula that will work every time. I did the first 3 problems because I want you to kind of know where they come from, but once we get this formula and prove that it has to be true, you can just use the formula for everything. Problem is it's kind of hard to remember the formula because it's so long from now. I know f of g of x equals x. So here's what I want to do. F of g of x. I want to take the derivative of both sides of this equation. So if I take the derivative of f of g of x, I have to use the chain rule. So the derivative of f would be f prime of g of x. And then I would have to multiply that by g prime of x. And what's the derivative of x? 1. Okay? Now, what we're finding here, f and g are inverses, so g is the inverse. Right? And what we're wanting is a formula for the derivative of the inverse, right? So what do I have written here that would be the derivative of the inverse? G prime, right? G prime of x, that's your derivative of your inverse. So if I want to solve this for the derivative of the inverse, I just divide by f prime of g of x. Okay, so g prime of x equals 1 over f prime of g of x. I prefer to do this with inverse notation instead of f of g of x. I did this first with f of g of x notation because I think it's easier to follow the process of that. But when it comes to actually doing these problems, I prefer to have the inverse notation because it helps me keep straight what I'm looking at. So let's do the same thing again, but let's use inverse notation. So I have f of f inverse of x equals x. So the only thing that's changing here is that I'm changing my g to the f inverse notation instead. So the derivative of f is f prime. I leave the stuff on the inside the same. But then I must multiply by the derivative of the inside, which will be f inverse prime of x. And then the derivative of x is still just 1. It's kind of ugly, but this right here means the derivative, that's the prime, of the inverse. Okay, derivative of the inverse. So if I want to find the derivative of the inverse, I just need to divide both sides by f prime of f inverse of x. And so, again, that formula for the derivative of the inverse is 1 over f prime of f inverse of x. So that's one that you want to know. And that is what we were doing on those first 3 problems when we did those like the alternate way. We found the inverse value, so we found the like that corresponding point, and then we took the derivative, and then we did 1 over that, which flipped it, which made it that reciprocal there. So let's look at a problem like this. Here is an example where you have to be able to use this because they don't even give you the equation. They just give you a bunch of information. Okay, so we are given that f of 4 equals 7, f of 7 equals 5, f prime of 4 equals 1/3, f prime of 7 equals 2/3, And we are supposed to find f inverse prime of 7. Okay? So, let's just use our formula. So if we're finding f inverse prime of 7, our formula we just used said it's 1 over f prime of f inverse of 7. So if we want to evaluate this, we would need to start by finding f inverse of 7. So that would mean, hey Jasper, what you need? Okay, thank you. All right, so f inverse of 7 right here means that 7 is the x-coordinate for the inverse. But that means but we don't have anything about the inverse, right? None of this, like they don't give any information about the inverse. So it's the x-coordinate on the inverse. What is it on the original function, on the f of x function? It is the y-coordinate. Where do you see that happen? F of 4, right here. There's your 7 as your y-coordinate. So the inverse that goes with it is 4. So we will have f inverse of 7 is 4. So that means now we've got 1 over f prime of 4. And then do we know f prime of 4? Okay, it is 1/3. And 1 over 1/3, dividing fractions, is easy as pie. Flip the second and multiply, and we just get 3 for our answer. Right. That most of the time on these, there'll be extra. A lot of times they'll ask you for it from like a table where there's a lot of different options, or they'll give you extra stuff to try to confuse you here, so that you might mess up on that. Because really, the only information you really needed was this and this. The other stuff's just distracting information. Okay. All right, so let's look at example 5. And this is more like you will find, this is what you will find on your assignment, mostly. This is what you will find on your assignment, but it won't be broken down into 2 steps. I'm just having you do that to sort of help us along here. So what it'll ask for in your assignment is it'll just say f inverse prime of 3. That is what it's going to ask you to find. Like, it won't break it into 2 steps. So, if we are finding f inverse prime of 3, we must do 1 over f prime of f inverse of 3. And so the first thing that we need to find would be the f inverse of 3, which is what I'm asking you for here in this first part. Now, why can I not just like find the inverse for this problem? Yeah, like if I wanted to do that, I have to find, like, flip my x and y's, right? And I'd have an y cubed and a y, and putting those together, I'm not sure if it's possible or not. And if it is, it's definitely not going to be easy. So this is an example of like an equation we can't really find the inverse for, or at least I don't know how. And it's not going to be easy if there is a way. So we're going to use the formula and work from the f of x equation instead. So if 3 is the x-coordinate on the inverse, what is it on the original? Y. So what that means is you will have like a 3 over here for your f of x, or your y-coordinate, and then you'll have 1/4 x to the 3rd plus x minus 1. And then I need to decide something here, because the only way to solve that is to use P's and Q's and division and stuff like that. And they usually don't put that on the exam. So, it's still okay. You won't just like be able to do the whole question without doing this. So let's just use Desmos or the calculator to solve this, right? So so if we're using Desmos, we can use the Scott-Wood method for solving equations, where we just do f of x equals 3 and g of x equals 1/4 x to the third plus x minus 1. Right here, like just graph the left side, graph the right side, see where they cross. And I'm getting 2, 3. So x here equals 2. And I'll let you guys do that because some of these you might be able to solve by hand, but some of them you may not be able to. So if it's something like this where like you don't know how to solve that by hand, just use Desmos for it. You could also use the solve feature on your calculator as well for that. So that is your F inverse, right? F inverse of 3 is 2. So now we must find F inverse of 2. I'm not F inverse, F prime of 2. So for that, thankfully, F prime is very easy to find, right? It's just a straight power rule problem. So F prime of x is going to be 3/4 x squared plus 1. And if I want to find F prime of 2, the 3 times the 1/4 here, right? You're just taking the derivative. Yeah, just power rule for that. And then he's older and wiser today, and still it's not working. So 3/4 times 3 squared. No, I'm sorry, we're plugging in 2, aren't we? I'll put a 3 there. 3/4, I guess, because it's the x coordinate there. 3/4 times 2 squared plus 1. 2 squared is 4, so 3/4 times 4 plus 1. The 4's just cancel there, and you'll get 4 as your answer for F prime of 2. But the derivative, so F inverse prime at 3 is going to equal 1/4. Most of the ones you're going to have for your assignment are going to be like this. So you're going to have an equation, and they're going to ask for F inverse prime of something. So your steps for that would be you need to find the inverse first. To do that, you plug in for the y and solve. And then you will need to find F prime of that value, and your answer will be 1/, whatever you get there. Okay? Let's try another one. Okay? And that should be F inverse of x, not F minus 1 right there. That should be F inverse of x. So it wants the derivative of the inverse at x equals -2. So this one I didn't break into steps. But if we use our formula, F inverse prime of -2 is going to equal 1/F prime of F inverse of -2. So the first thing we have to do is find f inverse of negative 2. What are we going to do to find f inverse of negative 2? Plug into the original for the y. So negative 2 equals 2x to the 5th plus x to the 3rd plus 1. Anybody know how to solve that quickly by hand? Me neither. So we are going to type it into Desmos. It can be done. I think it's like a P's and Q's synthetic division thing.
Yeah, what is that?
You remember doing synthetic division where you put like the numbers across the top? I have not seen, they used to put it on the exam, like if you look at really old problems from like the early 2000s, 90s, they're there, but I have not seen one in a very long time, so I don't think it'll be on there. It won't be on either.
Is that when we did the long division thing?
You can do long division, yeah. You like move everything to one side, then you gotta try to, you're factoring polynomials, but it's math 3. That's when you do it.
Yeah, I haven't taken math.
Like it look like this?
Isn't it like a kind of?
Yeah, you might have used a box for it. And you put all the numbers at the top, and then you gotta like bring one down and multiply and subtract.
I think I remember.
Kids can't ever remember it. Huh?
I think I kind of remember something like a T-chart.
Yeah, possibly. Yeah. So, we'll use Desmos. And what are we getting for our x?
We are getting negative 1.
Negative 1. So x would equal negative 1. So now we've got 1 over f prime of negative 1. So we must find f prime, which is not that bad to do for this problem, right? So, Xander, what do I get for my derivative of f?
10x to the 4th plus 3x to the 2nd.
Very good. And then I am going to plug in negative 1 to that. 10 times negative 1 to the 4th plus 3 times negative 1 squared. And that is going to give me just 10 plus 3, 13. So since this right here, 13, is f prime of negative 1, I'm just plugging it in. And my answer to the question is 1 over 13. Okay. Again, you have to do it this way because we can't find that inverse, right? We won't be able to find that inverse. Or if you can, I don't know how. Okay. Questions? All right. So 1 through 10 is your assignment. You got like 18 minutes. You might be able to get hopefully a lot of it done before you go.
Okay.